All right, ladies and gentlemen, let's take a look at example number 3, which says Chuck, a bird enthusiast who does research for the bird industry. Did you know there was a bird industry? There is. It's in the problem. Models the population B of Blackhawks T days after the start of the year with this function right here. So you input the day of the year. For instance, if it's January 9th, that's the 9th day of the year. Misspelled demonstration there. Yeah, let's do that. If you put in January 9th, that's the 9th day of the year. Here for T, T, and T, that will tell you here B will be the number of Blackhawks in our population on that date. Okay, so a few things that we're going to do here. One thing is we're going to try to find the maximum Blackhawk population. Second thing is we are going to try to find a range when the Blackhawk population is above 350. And then finally, we're going to find when the population goes extinct. So in order to do all of those things, we need to get a graph on our calculator. So without further ado, let's do this. You want to take this equation right here and put it into Y1. Okay, so it should look something like that. That's a little better. And, on this one, I'm pretty confident that zoom standard is not going to cut it because x would be going from -10 to 10. And since x in this problem represents time, and time is in days, and there's hundreds of days, that's not going to work. So what I want to do instead is go to our table here, and I'm going to start at 0, and I'm going to move by 1. And I'm going to look at the y values here. So I can see that the y values are growing as time goes by. And they're growing kind of slowly. Maybe I would like to move by an interval that's larger than 1 here. In fact, I'm going to go back to table set. I'm going to say, what if we start at 0 and we move by tens? Now I can get a better picture of, like, here's the Blackhawk population growing and growing and growing. And somewhere around right here, I noticed that it hits about its maximum. So somewhere between day 200 and day 220, the numbers start to go down. And then let's see how long they continue to go down for. They hit 0 somewhere slightly before day 400. So for the graph that we're about to draw, I'm going to say, let's make x go from time 0 until about 400. And then let's make y go from 0 up to, let's see, the biggest was something like 360 or so. So I'm going to go to window here. Let's say that time is going to go from 0 to 400. And then y, which is the number of birds, is going to go from 0 to, I'm going to go 370, because it looked like 360 something was the biggest. Then I'm going to hit graph. All right, and this is a good looking graph because we can see the maximum. We can also see when it hits 0. So maximum population, extinct. Let's throw that graph onto our paper. You can do this on your actual paper. I'm going to do it right here. I know that it goes up and then it comes down. And I'm just going to label for now that this is time in days, and that this right here is the number of birds or Blackhawks. Okay. So there's our graph. Now in B, it asks us to identify what the maximum is. So when we find the max, that means that we are looking for the y value at this instant. Everything okay back there, Odie? Okay, cool. And it turns out that the calculator actually has a maximum finder on it if you hit second and then calc. and then scroll on down to number 4 where it says maximum. Go ahead and enter. Now, much like it does with the zero finder and with the intersect feature, it's going to ask you for a left and a right bound. So I can't tell exactly what the x values are here. So I know that I'm a little bit to the left or a little bit below the maximum. So I'm going to hit enter right here. And then it asks me for a right bound. So I'm going to move my Space Invader guy past the maximum. I'm going to hit enter again. And then for guests, I'm going to move as close as I can to where I think the maximum is, and I'm going to hit enter. And there's our answer right there. The maximum occurs on day 212, and that maximum is this number. Now, you can't have 0.222 of a bird, so I'm going to say that our max, by the way, this is the answer to part B, is 365 birds. And it asked us, if it asked us for the day, I would say on day 212 of the year. Cool. So what does the next question ask us? It says the National Wildlife Service wants to contain the black hawk population to below 350 because too many birds make lots of messes. During what time interval will the National Wildlife Service take action to reduce the black hawk population? Well, if we look back at our graph, they're going to reduce the black hawk population anytime it is greater than 350. So let's suppose that 350 is right here. If that's the 350, then I'm going to draw a horizontal line. Everywhere from this time until this time right here, on this time interval, this is where the National Wildlife Service will be taking action. So what we want to figure out is what is the X value right here, and what is the X value right here, because those will be our times. The calculator will do this for you as well. You do need to go back to y equals and then go down to y2, and you need to graph y equals 350. Okay, and then just like we did in the last video, check out my last video if you don't remember how to use the intersect feature. We're going to do just that. We're going to use the intersect feature to find this point and this point. So I'm going to hit second calc, intersect, first curve, second curve. Now, you do actually have to move close to the one that you want so that the calculator knows which one you're looking for. And it looks like this happens on day 168. And then second calc, we do it all again. Intersect. First curve, second curve. Move as close as you can to that point. Hit enter. This happens on day 253, we'll call it. So the answer to the question for C is that the National Wildlife Service is doing containment when the time is greater than or equal to 168 days, less than or equal to 253 days. So there's your answer to C. The last question says, when will the bird population go extinct? And the bird population is going to be extinct when the number of birds is equal to, that's right, kiddo, 0. So we want to find the 0 at this time right here. And we simply do that by going back to the 0 finder, which we saw in our first video. And it's going to ask us for a left bound, right there. For a right bound, I know that because we looked earlier that at 400, we had a negative number for birds. So I'm going to hit 400. You can see there's my left bound. My right bound is right here. If I hit enter, it gives us that happens on day 392. So the answer to D is 392 days, or on the 392nd day.